Welcome to this lesson on using angle relationships. Today we're going to talk about using angle relationships to find missing angle measures. So we're going to use all of those different angles that we talked about previously, and we're going to use them and their properties to figure out missing angles. So complementary angles, we already said, are angles that make 90 degrees, and they can either be together or not. We're going to focus on angles that are together, that are adjacent. So in this case, if you have any lines that are perpendicular, we know that they make a 90-degree angle. But let's say we throw in this intersecting line through the middle, and now all of a sudden we have these different angles in here because of the fact that we threw in this intersecting line. So since we know, and I'll even put the symbol in here to show that it is perpendicular, so the little square implies that it's perpendicular. Well, if this is a perpendicular line, if these are perpendicular here and this makes 90, then you automatically know that the rest of these have to be 90, because ultimately what ends up happening is if you go around from start to finish, you have to make 360 degrees because there are 360 degrees in a circle. So if this is 90 degrees from here to here, the only other way for this to work is for all of it to be 90 degrees. Right? So because of the fact that we know that this is perpendicular, we can know that from here to here, so these are perpendicular. But the thing is, we have this line here that intersects it and makes two different angles within there. Well, if I don't know either of these angles, and I don't have any other information besides this, I don't have a way of figuring out my missing angle. So I'm going to give you that this angle is 63 degrees. Well, since that angle is 63 degrees, and we know that the two angles together have to give us 90 because we know that these are perpendicular lines, then I know that x has to be equal to 90 minus 63. Or what I can say is I know that 63 plus x, because they're complementary, has to give me 90 degrees. I end up subtracting 63 from both sides, and I end up with x is equal to 10 minus 3 is 7, 8 minus 6 is 2, so x is equal to 27 degrees. Okay, so now we know that this angle is 27 degrees because of the fact that we knew that this angle here and this angle here were complementary. Supplementary angles in linear pairs. So we have, and we're actually going to use one that's sideways. So here's a straight line. Like we said before, we know that if we were to take this and actually turn it, it'll make a straight line. We're just taking it and putting it on a slant. So it's still 180 degrees, even though it's slanted. And then now I'm going to intersect it with another line. Okay, but I already knew, and actually let's do this. I know that from here to here is 180 degrees, anywhere on that line. So if I take this line and intersect it, I know that where I break those angles into two, that this plus this has to give me 180. So it doesn't break itself apart and all of a sudden not become 180. It just goes from being one 180 degree angle to two angles that add up to 180. Right? So again, we need to know at least one piece of information here in order to figure out our answer. So let's say that we know that this angle here is 115 degrees and that this angle is x degrees. Well, I know that x plus 115 has to give me 180 degrees. So to find x, I'm going to subtract 115 from both sides. 10 minus 5 is 5. 7 minus 1 is 6. So I get x is equal to 65 degrees. So now I know that this angle here is 65 degrees. Right? So those are pretty simple for us. Let's take this one step further. So now vertical angles. First we have to be able to identify the vertical angles. So angle A and angle D are vertical. B and C, because remember they have to have that same vertex, and right here is the vertex, and right here is a vertex. So we have angle E and angle H, and angle F and angle G. So essentially, if you were standing in the angle, the person that you are standing and staring across at would be the person that makes a vertical angle with you. So H and E are staring at each other, so they would be the vertical angles. So let's look at B and D. Well, I know that B and D have to give me 180 degrees. I know B and D are supplementary. I also know that this is a straight line here, so I also know that D and C together have to be supplementary. So B and D are supplementary. And I know C and D are also supplementary. Since D can only be equal to one thing, and I know that, so B plus D equals 180, and I know that C plus D is equal to 180. So it's safe to say that B plus D has to be the same thing as C plus D, and I can cancel both of these pieces out. So I know that since D has to be the same thing, that B has to be equal to C. Because whatever you add to D, there's only one number that you can add to D to get 180. So I know, because of this, I know that vertical angles are congruent. And this is the symbol we use for congruent. Okay, or you can write congruent. So I know vertical angles are congruent. Same thing here. I know C and A are also supplementary. So that would mean that vertically A and D are congruent. So it always works out that A and D are going to be, or vertical angles are going to be congruent. Okay. Alternate interior and alternate exterior angles. So now this only works when you have, when the transversal, remember this is the transversal, is intersected by parallel lines. Okay, so these have to be parallel in order for this to work. So here I have B and C. We're working with alternate interior. So alternate interior. Well, I know that since these lines are parallel, they have to intersect this line, they have to intersect the transversal at the same angle. So they intersect the transversal Since they intersect this transversal at the same angle, then their angles in some way, shape, or form have to be congruent. Okay, so if we look at this, since this line intersects and makes this angle and they're parallel, then this angle also has to be the same. Okay, A and B are supplementary, so I know A plus B has to give me 180 degrees. I also know that E plus G has to give me 180 degrees. Okay, so with all that we know about these lines and about the transversal, we know that alternate interior angles are also congruent. So here, again, look at this is the exterior angle right here, A, and the matching exterior angle for this line would be E. And since they intersect at the same angle, so let's say that angle A is 105 degrees. Actually, let's say it's 110 degrees. And I know A plus B has to give me 180. So I know 110 plus B has to give me 180. I subtract 110 from both sides, and I get B is equal to 70 degrees. Well, we said that they intersect the transversal at the same angle. So if A is 110, then that tells me that E has to be 110 degrees. So by proxy, what ends up happening is I know that E and G are supplementary. And since A is equal to E, and E plus G has to equal 180 degrees, and I know that A plus B, then I know, so A and E are equal, so wherever I see A, I can actually put in E and vice versa. So I can actually say that angle A plus angle G has to give me 180 degrees. So that tells me that A plus B also has to be 180 degrees. So that tells me that B and G actually have to be congruent. So alternate interior and alternate exterior angles, so I can actually just leave this as both, are congruent. And alternate exterior. And we're going to use these relationships in a little bit to find missing measures, but this is why it works. So same side interior. So if I'm talking about B and E, this is where it gets a little bit confusing. B and E are not going to be congruent angles because we already said that alternate interior, so we know that B and G are congruent. So I know that G plus E has to give me 180 degrees. Well, since B is congruent to G, I can say that B plus E has to be 180 degrees as well. So, and we can say this is because of alternate interior angles. So I know G plus E is 100, and since G plus E equals 180, then we can say B plus E, so B plus E. So again, these two are congruent, so I'm going to highlight B and G are congruent. And then I know that G plus E gives me 180. So I know that B plus E has to give me 180. So I know that same side interior angles are supplementary. Okay, so what this means is we can actually use, as long as you can figure out, as long as you have one angle measure, you can find all the rest of these angle measures using different rules. So what I'm going to have you do, I know we didn't really go through a lot of examples here, but use what you know. So you know that if you go back into your rules, vertical angles are congruent. Alternate interior and alternate exterior are congruent. Now I want you to make sure you understand the alternate interior angles are congruent to each other and the alternate exterior angles are congruent to each other. It's not that B and G are equal to F and C. They're their own separate things, but their proofs work out pretty much the same. Okay, and then same side interior angles are supplementary. So what you're going to do is you're going to figure out what is the measure of angle G and then what angle relationship tells you that. So is it the fact that they're vertical? Is it the fact that they're supplementary? They're alternate interior, alternate exterior? Okay, so I want you to find the measures of angles G, F, and D and then tell me what relationship told you how much each of those angles are. As always, if you have any questions, please be sure to write them down or email me so we can go over them in class.